Imagine walking along the eroded banks of the Drouzet watercourse in the Southern French Alps. Amidst the natural beauty hidden in these banks lay secrets from over 14,000 years ago, preserved within the subfossil Scots Pines. These preserved trees have borne witness to the Earth's climatic and solar changes, and recent research has unlocked their hidden stories, revealing unprecedented insights into our planet's history. The crux of the investigation lies in the radiocarbon method, a technique that has been instrumental in dating fossil samples for up to 55,000 years. During the study, scientists analyzed about 400 new radiocarbon ages from 15 subfossil trees at an annual resolution. What they found was extraordinary. An abrupt radiocarbon spike occurring within a single year at 14,300 to 14,299 years before the present, and a century-long event spanning from 14,000 to 13,900 years before the present. To determine the origins of these radiocarbon anomalies, the researchers compared the Drouzet radiocarbon record with simulations using beryllium-10 data from Greenland ice cores. The correlation revealed compelling insights. The 14.3 thousand years before present spike coincided with a solar energetic particle event, while the century-long event was linked to a Maunder-type solar minimum, a period of reduced solar activity. This century-long minimum intriguingly overlapped with the brief cold phase known as the Older Dryas. The identification of these radiocarbon spikes provides more than mere chronological milestones. They offer a functional probe into Earth's carbon cycle. The abrupt spike and subsequent decay at 14.3 thousand years before present, and the century-long radiocarbon event present an impulse response function, a concept used to characterize the global carbon cycle's reaction to sudden changes. The researchers compared these findings with carbon cycle models to better understand how different carbon reservoirs, like the atmosphere, biosphere, and oceans, interact during significant solar events. Collecting samples from these ancient trees was no small feat. Over 172 subfossil trees were discovered in a single stretch of the Drouzet River, with each tree bearing witness to climatic events spanning centuries. Dendrochronological analyses, which involve counting tree rings, detailed the growth patterns disrupted by geomorphological stresses, such as frequent floods. This careful examination allowed researchers to build a continuous timeline that could accurately place these trees within a larger chronological framework. The study employed a Bayesian Markov chain Monte Carlo scheme to refine the matching of the floating radiocarbon sequences from the Drouzet trees with the absolutely dated German pine chronology. This meticulous alignment ensured that minor chronological mismatches did not distort the interpretation of the radiocarbon data. By integrating cosmogenic isotope data from both tree rings and ice cores, the researchers forged a robust model that reconciled solar event timings with radiocarbon and 10B fluxes, affirming the cosmic origin of the discovered radiocarbon anomalies. The Older Dryas event, characterized by a century-long radiocarbon anomaly, created intriguing questions about its possible climatic impact. The researchers found that the timing of this solar minimum paralleled a brief cold phase, suggesting a possible link between solar activity and climatic changes, albeit acknowledging that other factors likely contributed. While direct solar forcing alone might not fully explain the climatic cooling, the study underscores the complicated interplay between solar events, climate shifts, and the global carbon cycle. The insights gathered from the Drouzet subfossil trees lay the groundwork for future explorations. The research emphasizes the need for higher time resolution sampling in polar ice cores and replicating radiocarbon records across different geographic locations, including the Southern Hemisphere. By enhancing the spatial and temporal resolution of these records, scientists can better reconstruct the history of solar events and their broader impact on Earth's environment and climate. This story isn't just about ancient trees, it's about the intricate dance between the cosmos and our planet, a story still unfolding with every new discovery.
My name is Ricardo Valls. I'm a professional geologist registered in the province of Ontario, Canada, and also the president of Valls Geoconsultant. Geology, geochemistry, structural analysis, machine learning, and artificial intelligence. I am sure you will find something useful among my over 550 videos.